Hi everyone. In this video I'm going to be going over a problem-solving method called the comparison method, and we're going to use it to look at two Regents questions. So the first one is question 3 from the 2023 Physics Regents. It says, the same net force is applied to object A and object B. The mass of B is 3 times greater than the mass of A. Compared to the acceleration of A, the acceleration of B is the same, 1/3 as great, 3 times as great, or 1/9 as great. So the comparison method basically is where you pick a formula, then you plug in 1 for anything that doesn't change, then you plug in the appropriate number for variables that do change, then you solve, and then you use keywords to determine your answer. So the keywords that I have highlighted are things like quartered, 1/3, halved, the same, doubled, and so on. So all of these keywords are kind of hints that you might be using the comparison method to begin with. Like if we look at the question, we see a lot of these keywords here. So they're not really asking us to solve for the acceleration, like get an actual number in meters per second squared. They just want us to compare how the acceleration of B is different than the acceleration of A. So we're going to look at these keywords again once we solve the problem. Normally the way I start problems is I circle the numbers and units, and I underline the unknown, and I box the keywords. But since I don't really have that many numbers, it might look a little bit different, but I do see the word 3, so I'll circle that. I'm solving for the acceleration of B, or rather that's what the question is asking me about, so that's what I underlined. And I underlined same net force, because that tells me something about the force. I'm going to be plugging in 1 since it's the same. And I put a box around mass of B because that's the thing that's 3 times greater than the mass of A. So I'm going to start by picking a formula. And I picked A equals F net over M. And even though I don't really have my variables listed, I know that I'm looking for acceleration and I'm given some information about a net force and a mass. So this equation is a perfect match. The next thing I'm going to do is plug in 1 for something that doesn't change, and plug in the appropriate number for any variables that do change. So I also am going to just list my unknown. A is my question mark. That's what I'm solving for. F net is equal to 1 because they say same net force. So if F net is the same, I plug in 1. M is equal to 3 because the mass of B is 3 times as great, or 3 times greater than the mass of A. If it doubled, I would have plugged in 2. If it was cut in half, I would have plugged in 0.5. So the one that changes could be a bunch of different numbers. You just have to read the question to see what number. But the one that doesn't change, or if you have a formula with more than just 2 variables to plug in, usually everything usually stays the same except for 1 variable. Although not every time, but most of the time. So if it doesn't change, you're just plugging in 1. If it does change, it could be a few different numbers, but you'll just read the question to see. Now I'll plug in those numbers, 1 for F net and 3 for M, and basically my answer is 1/3. You can plug that into the calculator to solve that, to get a decimal if you want, and then kind of use the keywords to determine your answer. I see that 0.33, if I plug it into my calculator, this is what I would get, but I also just see 1/3, and I see the word 1/3. So it's pretty clear to me that my answer is 1/3 as great. The next one I want to look at is something that we can sort of use the comparison method for, but not completely. So I'm just going to start this problem in this video, and you can try to continue it on your own. So this question is question 38 from the Physics Regents from 2023. So it says, the table below shows the weight of 4 athletes, A, B, C, and D, and the time required for each athlete to run from the base of a hill to its top. Which athlete ran up the hill with the greatest power? So I'm starting to think maybe I can use the comparison method because we're definitely comparing 4 different athletes. The only thing that's giving me trouble is these aren't easy comparisons to make. It's not like I can clearly see that something doubled or tripled. 600 to 650 is not like an obvious number for me. So maybe I'll be able to use it, maybe not. But let's start by annotating. If I underline my unknown, I'm going to underline greatest average power because I'm looking for the power and I want to make sure I remember I want the greatest power. That's what I'm trying to solve for. So I wrote P equals question mark. I also want to put a note on this table to remind myself that if I know the weight of each athlete, I basically know the force because weight is a type of force. So just a reminder that this is really a column that tells me the force. So basically I know what the force is going to be. I'm going to have to solve this problem 4 different times, 1 for each athlete, but I'm writing down F equals because that's something that's basically been given to me. I definitely know what the force is for each of these athletes. I also definitely know the time because they gave that to me. Again, I'm going to have to solve this 4 different times, so I'm not filling it in with anything specific yet, but I definitely know that information. So I want to see if there's a formula for power that involves force and time. And I see power equals force times distance over time, and I just don't have the distance. That's not given to me anywhere in the problem. So my solution for that is I'm just going to call it 1 meter. It didn't change. It's the same hill for each athlete. So why not just say it stays the same, which means I'm just going to put 1. So that's kind of my setup for this problem. The power is always what I'm looking for. I'm always going to say that distance is 1. And I'm just going to plug in my different values for force and time. 600 and 11.8. 650, we'll go with 10.7. And I'm going to solve this problem 4 times. Of course, I still need to pick an equation, but I'm going to use this one, power equals force times distance over time, because this is the one that I have the most information about with my force and my distance. So to try to solve this problem, you should do 4 different calculations. Basically plug in your numbers to this formula for A, B, C, and D, and remember you're looking for the greatest average power. So see which one gives you the biggest number.